Hello, welcome. I'm Sandhya, and I'll take you through another topic of Unit 3, Chapter 2 of the course Programming for Problem Solving in this video lecture that is all about blocks and storage classes. So what are we going to see in this video is what is a block, how do we work with nested blocks, what are the properties of a variable, do they differ or do they vary, and what is called a storage class, what are its types, and a few examples. So this is what we'll be seeing in this video. So let's move to understanding block and nested blocks. So basically, block is a word that we have been using from a while now. That is, if I write, I write a if condition, open bracket, close bracket, I write some statements inside that. I write a while condition, open bracket, close bracket, write some conditions, write some statements inside that. Yes, exactly. So in computer programming, a block or a code block is a lexical structure of source code which is grouped together. Group means you open and close a bracket and put some data inside it or instructions inside it. So a compound statement, also called as a block statement or a block statement, is zero or more statements that is treated by the compiler as a single unit. A programming language permits creation of blocks, including nested blocks, etc. is called as block structured programming language. And essentially C supports all that. So you can call C as a block structured programming language also. So, okay, a block consists of one or more statements that will be executed. So blocks begin with an open brace and ends with a closed brace, and will have statements inside that. No semicolon is needed for the end of a block. You need not terminate any block with a semicolon. Branching statements, conditional statements, loop, switch, etc. All of this will have blocks. Okay, so variables declared inside a local block will only have local scope. Okay, before we go further, then comes the next question: can a block be nested? Yes, of course, you can have nested blocks, and all that we'll see as we go by. So let's just take this example for understanding what is a block. A block is a group of instructions enclosed in open and closed parentheses. So int main, int x is equal to 10. So inside that I wrote x is equal to 30, printf percentile dx, close printf percentile dx. So there is only one variable x, but this is defined inside this block. It will be legal from this open bracket to close of main. But inside that I redefined x with 30, reinitialized x with 30 and print x. So therefore, when I print this x, x gets 30, but this value is not reflected in the, in the outer block because this limitation is only to this inner block. Okay, so that's why x again gets the value 10. So this is an example program. Okay, so we'll proceed to understand example of this block. See here, this is another example. Here x is equal to 10. So I'm trying to print the value of x. I'm trying to print the value of x inside this block. Do you have x defined here? No, we don't. X is not accessible here because there's an issue here. X is opened here, closed here. So that's why to this block, these becomes two separate blocks. This is block 1, this is block 2. Block 2 x is not defined, so therefore it throws an error. The answer is error. But it would be a different case if there is no close bracket here. Please understand. Okay, that's the difference. That makes a lot of change. Okay, so yes. Here x is defined, it's kept open still. So that's why x is accessible till here. But here x is defined and closed, but accessed in another block where it does not have its existence. So therefore it throws an error. So this is about blocks, and blocks can also be nested. These are a few examples. So yes, what is called a storage class? Okay. Do all the variables wherever we write have same properties in C language? No, variables exhibit different kinds of properties. So what is that which determines the different kinds of properties exhibited by variables? It's the storage class that determines the various properties exhibited by variables. So every variable has its own memory wherever it is stored. Memory requirements of variables depends upon the data types of the variables. From C compiler's point of view, a variable name identifies some physical location within the computer where the string of bits that it stores are stored. So a variable in C differs in behavior. The behavior depends upon the storage class of the variable. So what does the storage class determine? The term storage class itself means a lot of things. The term storage class means, the manner in which a particular variable is accessed, stored, and, limitations. The manner in which, what is the scope of that particular variable? What is the extent to which that variable can be used? All these are clearly determined by something called as storage class. So how many storage classes does language C support? Language C support essentially 4 storage classes: automatic, register, static, and external storage class. Automatic storage class, register storage class, static storage class, and external or external storage class. Yes. Let's go ahead and look at automatic storage class. Every storage class has got a keyword, and the keyword for automatic storage class is auto. The place of location is nothing but storage. It is stored in memory. Default initial value is garbage, an unpredictable value which is called often as garbage. The scope is only limited to the block in which declared. We have seen it already. The scope is only limited to the block in which it's defined. And the lifetime is only till the control remains in the block. As long as the control is in the block, the value exists. Once the control goes out of the block, the value gets deleted. Okay, this is a default storage class. A variable assumes whenever you declare it inside any block. That means though I write int I or I write auto int I, it means the same. That's what it means. You write int I or you simply write auto int I, it means that it is automatic. That's the point that people are describing. Okay, so there is I which is given 10, open a bracket, I which is given 20, open a bracket, I which is given 30. So in block 3, this value is only within this block because automatic variable's existence is only in the block. So therefore, I gets 30 in block 3. In block 2, this is the variable. It is defined inside this. So I gets the value 20 and I gets the value 10. So therefore, the answer would be in block 3, it is 30. In block 2, it is 20. And block 1, it is 10. This is also an example for nested block. Here, though I write auto or not, it means the same because all the local variables by default assumes a storage class of auto or automatic, and the keyword is auto. Okay, so let's move to understand the next one. What is the default value? If I try to predict the default value of an auto variable, I just wrote auto int ij and I'm printing ij, I'll get some garbage values because the default value of automatic variable is garbage. Likewise, the default value of register is also garbage. Okay, so local versus global. So I have a global variable. Something that is declared above the main in the global declaration section becomes a global variable. So int I is equal to 10. Here I have auto int I is equal to 20. Now when I'm trying to print I, which I does the computer determine? Is it an error? Is it 10 or is it 20? Is it unpredictable? My dear boys and girls, it's not error, it's not unpredictable, it is clearly predictable. Whenever a local and a global variable has the same name and being accessed, the local gets more priority over the global. So therefore, do I have I defined here? Yes, I is defined here. What's the value of I defined? 20. So therefore, the answer would be 20. This is needed to be remembered because this makes a lot of difference in a lot of programming. Okay, so then comes static storage class. What is all about static storage class? Yeah, static, as the name says, is fixed. So therefore, the keyword is static. The storage memory location is memory. It's fixed values. The default initial value is 0. Just like static, external default value is also 0. The scope is local to the block. It only scope is nothing but existence. Which block is it existing? File scope, block scope, function scope, prototype scope. All that are the variable scope, various scopes available. So the scope here is just defined to the block in which it is defined, but the lifetime is still the program is under execution. As long as the program is under execution, it will have its values retained. There are few points that needs to be remembered while we go ahead and talk about static variables. The first one is static can have two forms, static local and static global. I define above memory becomes static global. I define inside the main becomes static local. Static variable is initialized only once and can never be reinitialized because it retains its values. It has the ability to retain the values. So for example, I have this program. There is a fun1. I'm calling thrice this function. Whenever fun1 is called, you go here. Fun1 is a function 1. So control jumps here. Static int x is equal to 1. Sets x is equal to 1. Value of x is equal to 1. You get the answer. Then x plus plus x becomes 2. But because this is a static variable, the value is only available inside this block, but it is retained. So x is equal to 2 is retained. You go back, fun1, you call again. So you come back. It is not initialized again because static variables are initialized only once and can never be reinitialized. So value gets 2 and so on. For the third call, value gets 3. So therefore, you can understand one of the usages of static variables is you can find out how many number of times a particular function is invoked using static variables. How many number of times a particular function is invoked can be remembered by using a static variable. That's the first thing. And the second thing is static variables persist with their values in between the function calls. That's the second and most important. If you want your local sub-program to remember the value of a particular variable and use it in the next iteration, then you got to use a static variable because auto doesn't do this business. So yes, here I'm trying to predict the default value of a static variable. We all know that the default value of a static variable is 0. So when I just try to initialize static int I print its value, I get the value 0. Here is an example where I'm trying to understand a static variable versus a local variable, nothing but an auto variable. Okay, so here I have called the function thrice, just like in the previous case, but I have a static variable x and the same local variable y initialized to 1. X is incremented, y is incremented. You can observe the change here. This is the output of this particular code. The output is pretty clearly there on the screen. Value of x is 1, value of y is 1, value of x is 2, y is 1, x is 3, y is 1, because auto has, auto itself means the moment you are out of the block, the value dies. In other words, it does not, become valid again. So therefore, auto variables do not retain the values whereas static can. This is an example where you can clearly show static versus auto or static versus local. Okay, so one point, that is, if I try to access those static variables retain their value, if here, inside the main program, if I write printf %dx, it throws an error because static variable scope is only inside the block in which it is defined, but the value defines. But the ability to retain the value is the one that makes it different from auto. Okay, so register class. The next one is register class. If something is stored in CPU registers, if some variables are stored in CPU registers, it's called as register class, and the keyword is register. Okay, the keyword is register. The keyword is register. The default value is garbage, and the scope is only inside the block, and lifetime is only within the block. Now, register variables are purely dependent on machine. The choice clearly depends upon machine. It is illegal to use ampersand with register variables. So register is the keyword that is used to access this variable. They are stored in RAM. So that's why they make the access faster, because they are stored in RAM. And it all depends upon the compiler or the machine. If it has a lot of memory available, it treats something as register. Otherwise, it sets them as auto variables. That's it. If you try to declare more register variables, then it treats them as auto variables, as the memory of processor is fixed and limited. So that's why the garbage, the default value is also garbage. Example, register int I, they become faster. You can check out on the execution times. The output is 1, 2, 3, 4, 5. Yes, here is an example of one more. If I try to print the default value of a register variable, then register int I. If I try to print the default value, I get garbage. On the other hand, if I try to put ampersand with a register variable, because register variables are not stored in memory, but they are stored in RAM, or the processor's registers, they are not stored in registers, they are stored in registers, it becomes extremely difficult. So that's why, ampersand writing is illegal. You can't do that. Next is external variables or storage, external storage class, or in other words, people call it in two ways. People call global as external, but there is a small slight difference between global and external. For time being, all of you understand global storage, and then we'll differentiate depending upon the necessity of the thin line between global versus external. The keyword is extern, the storage is inside memory, the default value is 0, the global scope, they exist as long as the program is under execution. So this becomes a default storage class for a variable if it is declared above main. Above main function, if you declare something, it becomes default storage class. Okay, so here int num is 75, I'm using here. If you want to use it here, you can write extern int num, or you need not even write it. That's not an issue. Okay, so this is how it is. This is how it works. But suppose the advantage with external variables is if you want to use variable in one file, also in another file, then this extern becomes very, very handy. Auto doesn't work, static doesn't work, because static is also file scope, but extern works. That is the advantage of extern. Extern finds it usage, that's what it's written. Keyword extern is used in declaring a global variable or a function in another file to provide the reference to the variable or a function that have been already defined in original file. If you have two files and if you want one value to be reflected in the other one, then extern is the better choice. Okay. So here is a small comparison of all these storage classes. Declaration is inside a function or block. Register is also inside something. Extern is outside or above all. Static is also static local is inside and static global is above. Likewise, storage is memory. Registers are CPU registers, memory, memory, memory. Auto and register will have garbage or unpredictable values, and extern will have 0, 0, 0. Extern and static will have 0. Scope is within the block of auto and register, whereas extern and static is also within the block, whereas extern will have file scope and static global will have global scope. So this is about the lifetime. Lifetime is how long is it accessible. That's what is the lifetime. Okay, so dear students, before we close, I recommend you to understand storage classes, because that clearly differentiates and gives us large amount of freedom to write codes in a better way. Good day.